In this video, we are going to learn about the excess pressure inside liquid droplet, excess pressure inside soap bubble, and excess pressure inside liquid jet. So we will now calculate the excess pressure inside a liquid droplet. So as you can see, this is liquid. This complete blue shape is representing a liquid droplet. Outside it is air. Here it is air. Now, if you try to analyze it, so we will talk about the surface area. Where is the liquid water interface? So when we talk about the liquid water interface, so we are referring to this particular line. Please follow this yellow line. This will give you the liquid water interface. So if we talk about this interface, so definitely there will be surface tension acting. So as you can see, the surface tension, it should be multiplied by the length upon which it is acting, then it will give you the value of force. We know that sigma value is equals to force per unit length. That also means that if you want to calculate force, we can write it sigma into L. We can write like this. So what is this L value here? So we can see that this L value is this circumference of the circle. So that is sigma s multiplied by 2 pi r. This is the value can be given for force. Let us take it as our first equation. Now, what is the pressure difference? Now, when we talk about pressure difference, so we are talking about what is pressure outside and what is pressure inside. So we are talking about these two things. So that is excess pressure. So remember, excess pressure we are going to represent as delta P, and sometime it will be P. So do not get confused. Either some books they will show that it is delta P and some book they will show P, because in statement they have already mentioned this is excess pressure. So that means it is the pressure difference which they are referring. Pressure difference where? Pressure difference inside this droplet, pressure difference outside this droplet. So what should be the pressure required? Now this pressure, how we can get? The pressure multiplied by area will also give you the value of force. So now if you try and focus, you will come to know that this is the surface area. Look at this. This is complete surface area on which this pressure is acting. So we can easily determine the value of force. How? So again, the force here must be equal to the previous one for equilibrium. And how it can be calculated? So this is obviously the excess pressure multiplied by the area. Now what is area here? Pi r square. So this is equation 2. But we know from our understanding, now suppose if this is F1 and this is F2, both forces are, let us take different. So we know that for equilibrium, F1 must be equal to F2, or in other words, we can write delta P into pi r square must be equal to sigma s into 2 pi r. So if you look at this, so we know that this pi and this pi will get cancelled. This r will get cancelled with this one of the r. So we can write here delta p can be given as 2 sigma s upon r. This can be one of the expression for excess pressure calculation for a liquid droplet. Now this excess pressure can also be written as delta P is equals to, now R can be written as, R value is always diameter by 2. So R can be written as d by 2. In that case it will be 4 sigma s upon diameter. So if we talk about diameter, then we can express in this value. Delta P can be equal to 4 sigma s upon d. So both are important. Keep them in mind. Now moving on to the excess pressure inside the soap bubble. Now if you see here, so there are two surfaces. Now again here it is air, this is liquid, and inside also there is air. So in that case there will be two surfaces in contact. So again, like the previous case, we can balance both the forces. So the force F1 was due to surface tension. So sigma s multiplied by area. Sigma s multiplied by the length. So what is the length? Length is again the circumference. This total circumference. This is the length. So what we'll write here? We'll write here sigma s multiplied by 2 pi r. But this is only the one side of it. The other side will be same, so we will multiply it by 2 because now there are two interface. This is outer interface and this is inner interface, so be careful, there will be two surfaces. This is equation 1. Now the other force, because of the pressure difference, so we will write this is equals to delta p multiply by the area again will be pi r square, that is our equation 2. But for equilibrium again, for equilibrium, we know that F1 must be equal to F2. So we can write our equation as delta P into pi r square must be equal to 4 pi sigma s into r. Now again, this pi and this pi will get cancelled out. This r and this r square, one r will get cancelled out. So we can write our equation as delta P is equals to 4 sigma s by r, which can also be given as 8 sigma s by d. Remember this, that expression can be given in terms of radius or it can be given in terms of diameter, both, right? So this is also important. You should keep this. Next, moving on to the excess pressure inside liquid jet. So as you can see here, the surface in contact,